Hello and welcome back to class. Today we're talking about matrix multiplication. Our objectives are 1. To state the conditions necessary for multiplying two matrices. We're going to look at the transpose of a matrix and why it may be necessary. And then we're going to multiply two matrices together. And finally, we're going to show whether or not matrix multiplication is commutative in general. So first up, what are the conditions necessary so that we can multiply two matrices together? Well, if we want to know if two matrices can be multiplied together, the first thing we can look at is their size. If they are the same size, that guarantees that those two matrices can be multiplied together. And the resulting answer matrix will be the same as the matrices that were multiplied. 2. If the number of columns in the first matrix is the same as the number of rows in the second matrix, then those two matrices can be multiplied as well. In that case, we would have to look on a case-by-case basis as to what the size of the answer will be. Let's look at these examples. Here we have a matrix with 2 rows and 2 columns. And here we have another matrix with 2 rows and 1 column. So let's write it down. A is a 2 by 2 matrix, and B is a 2 by 1 matrix. Look at the numbers on the inside. That is the number of columns. So we have rows, columns, rows, columns. So the number of columns in the first matrix is exactly the same as the number of rows in the second matrix. That tells us that they can be multiplied together. The numbers on the outside tell us the size of our answer. So the size of our answer matrix is going to have 2 rows and 1 column. This is important when multiplying so that we don't get lost in deciding what our answer should look like. So the inside numbers tell us that the matrices can be multiplied together, and the outside numbers tell us the size of the answer. Here we have a 2 by 2 matrix, 2 rows, 2 columns. Here we also have a 2 by 2 matrix, 2 rows and 2 columns. So yes, these two can be multiplied together because they are the same size. Here, this matrix has 2 rows and 3 columns. This matrix has 3 rows and 1 column. So can they be multiplied together? The inside numbers are the same, so yes, they can be multiplied together. The outside numbers tell us the size of our answer. So your answer matrix would have 2 rows and 1 column, which would look something like this. 2 rows and 1 column. So let's look at some more. Sometimes in trying to multiply a matrix, we realize that the order in which the multiplication is stated cannot happen. For example, here we have a 2 by 2 matrix, and here we have a 2 by 1 matrix. This multiplication is possible as it is, because the two numbers on the inside here are the same, so yes, they can be multiplied. However, in this case, calculating mn, we have 1, 2, 3 rows, and we have 2 columns, and this matrix has 3 rows and 1 column. If we want to calculate mn, then we realize that the multiplication as it is stated cannot happen. So what do? In order to fix this problem, we can transpose the matrix. To transpose the matrix means that we change the rows into columns and the columns into rows. What we want is for these two numbers on the inside here to be the same. At the moment, they're not the same. This one has a 3, this one has a 2. However, this matrix does have a 3 in terms of the rows here. So if we switch around the rows and columns here by transposing this matrix M, we can get it to look like a different matrix, and therefore we can multiply M by N. So let's transpose matrix M by turning the rows into columns. Now this is the first column, so we're going to turn it into the first row. So we write MT to mean M transpose, and we're going to turn this start with this first row first column rather, and it becomes the first row. So we have 1, 0, x, and the second column becomes the second row, 2a, 7. All right, we have transposed it, and now it is now a 2 by 3 matrix. So now we can check it against the other matrix, 3 by 1, and now we realize that the two numbers are on the inside are the same. So yes, whereas here, no. So yes, they can be multiplied together now because the numbers on the inside are the same. So from time to time, it's important when you're doing a multiplication, when the matrices are not the same, that you can transpose a matrix if the original order in which they're given is not, they're not arranged so that they can be multiplied. You can always transpose one to fit the multiplication that you need. All right, now let's talk about how we multiply actual matrices. We multiply a matrix by multiplying a row by a column. So this is a row and this is a column. We multiply rows by columns. Let's start off this one. Now we did a check on this one already. This one is 2 by 2 and B is 2 by 1. So we are sure that they can be multiplied together. Also, we know that our answer matrix is going to have 2 rows and 1 column. So it will look something like 2 rows and 1 column, something like this. So let's multiply. So we have AB 1, negative 1, negative 2, 3, that's A, and B, negative 1, 2. What we're going to do is multiply each row by this column. So we're going to take this row, 1, negative 1, and we're going to multiply it by the column, negative 1, 2. And then we take the second row, negative 2, 3, and we're going to multiply it by the same column, negative 1, 2. This is the basic idea of how you go about multiplying a matrix. This process is just repeated according to how many rows and according to how many columns the matrix has. So in multiplying, we go first to first, second to second. First to first, second to second. First to first, second to second. So in multiplying here, we have a 1 times a negative 1. 1 times negative 1. And negative 1 times 2. We always use a plus to join them. So 1 times negative 1 plus 1 times negative 2. 1 times negative 1 plus negative 1, rather, times 2. All right, now that we got that. Second, we go down to the other row. Negative 2 times negative 1 and 3 times 2. So row by column means 1 times negative 1. There we have it. And then this negative 1 times that 2. There it is. And then row times column, this negative 2 times that negative 1. There it is. And this 3 times that 2. Once we're finished with that, we can simply do our arithmetic and get our answer. So 1 times negative 1 here is negative 1. Negative 1 times 2 gives us a negative 2. Negative 2 times negative 1 here gives us 2, and 2 times 3 gives us 6 here. So our answer, our final answer becomes AB equal to negative 1 plus negative 2, that gives us negative 3, and 2 plus 6 here gives us 8. And this is the answer for the matrix product AB. All right, let's try another one. Here we have matrix A, and we're going to find A square. Let's do that. So A square means that we're going to multiply A by A. So we write down our A. These two matrices are the same size. So we do not have to worry about what our answer will be. Our answer will be a 2 by 2 matrix. So it's 1, 4, negative 1, 2, multiplied by the same 1, 4, negative 1, 2. So we're going to take this row, multiply this column. So 1, 4 is going to multiply 1, negative 1, 1, negative 1. So 1, 4 multiplies 1, negative 1. Then 1, 4 is going to multiply 4, 2. Then we go to the second row, negative 1, 2 is going to multiply 1, negative 1. I'm writing it out, taking the long road here so that you can see the pattern. And then this row multiplies this column. So negative 1, 2 is going to multiply this column 4, 2. So notice 4, 2 here, 4, 2 here, 1, negative 1. These two are the same, these two are the same, these are the same, and these two are the same. All right, so it's row times column, then row times column, second row times column, and row times column. All right, let's do the multiplication. So we have now 1 times 1, which is 1. 1 times 1 plus, I should write this down here to make it a little bit more easier to look at rather than going across the screen. So let me drop it below it. So 1 times 1 gives us 1 plus 4 times negative 1 is negative 4. Going across still, 1 times 4 is 4 plus 4 times 2, that gives us 8. Second row, negative 1 times 1 gives us negative 1, and 2 times negative 1 here gives us a negative 2. And then here, 1 times negative 4 gives us negative 4, and 2 times 2 gives us 4. Let's put those together and see what we get. So a squared is going to be equal to 1 plus negative 4 gives us negative 3. 4 plus 8 gives us 12. Negative 2 plus negative 1 here gives us a negative 3 as well. And negative 4 plus 4 gives us 0. And this is what a squared ends up looking like. Row times column, row times column, and we get our answer. Here, we're going to multiply another row by another column. So we have this matrix Mn. It is written as Mn, so we're going to write it down. This is 1, 2, 3 by 2, and this here is a 3 by 1. As it is right now, it's not possible, so we're going to transpose it. So we transpose M. M transpose becomes, let's write that a little bigger. M transpose becomes, we take this row, this column, turn it into a row, this column, turn it into a row. So this first column becomes the first row, 1, 0, 4, and this second column becomes the second row, 2, 5, 7, and we're now going to multiply it by 6, 0, 3. So we have the matrix product Mn. When you're multiplying matrices, it is not a good thing to reorganize your product. So if the question says calculate Mn, you should actually calculate Mn and not the other way around. We'll discuss that in a moment. So here we go. Row times column. This is now 2 by 3, and this is 3 by 1. So our answer is going to be a 2 by 1 matrix. Looking at the outside, 2 by 1, which means 2 rows and 1 column, just like this. So let's do the multiplication. 1 times 6 plus 0 times 0 plus 4 times 3. And then 2 times 6 plus 5 times 0 plus 7 times 3. Let's see what we get at the top. 1 times 6 is 6. This is 0. This is 12. This is 12. This is 0. And this is 21. So we have 6 plus 12 here. That gives us 18. And then we have 12 plus 21, which gives us 33. So the matrix product Mn would be equal to 18 and 33. Finally, we're going to look at matrix multiplication and it being commutative or not in general. So here we have two matrices, A and B, and we're going to look at the matrix product AB, and then we look at the matrix product BA and compare our answers to see if they're the same. Remember that for commutative, 2 plus 3 is equal to 3 plus 2. That's for addition. And for multiplication, 2 times 3 is the same thing as 3 times 2. That's what it means to be commutative in addition and in multiplication. We're going to try it here to see if it works for matrices in multiplication. So let's write down AB. A is 1, 0, negative 2, 3. And B is 3, negative 5, negative 1, 2. So we make sure that we write them in the order that they appear. This is A, this is B. Now let's multiply and see what happens. Negative 1, so we're going to go row by column. Row by column, so 1 times 3 is 3. 1 times 3 is 3. And 0 times negative 1 is 0. This row now times this column, 1 times negative 5 is negative 5. And 0 times 2 is 0. Second row, negative 2 times 3. So we're going to go row by column. This row by that column, negative 2 by 3 gives us negative 6. And 3 times negative 1 gives us negative 3. Now this row times this column. So negative 2 times negative 5 gives us 10. And 3 times 2 gives us 6. Our answer, therefore, is 3, negative 5, negative 9, and 16. And this is what AB is equal to. Now let's look at BA. So BA, we write B first, which is 3, negative 5, negative 1, 2. And we multiply that by A, which is 1, 0, negative 2, and 3. All right. So here we go. Row by column. So 3 times 1 is 3. 3 times 1, the row times column. 3 times 1 is 3. Negative 5 times negative 2 gives us a positive 10. Row by column, 3 times 0 is 0, plus 5 times negative 3, or negative 5 times 3 rather, is negative 15. Second row, negative 1 times 1 is negative 1, plus 2 times negative 2 is negative 4, and negative 1 times 0 is 0, and 2 times 3 gives us 6. When we add that up, we get 10 plus 3, 13, negative 15 for that part, negative 4 and 1, negative 1 here gives us a negative 5, and 0 plus 6 is 6. And this is what BA is equal to. So we have it that AB, when you compare them, you realize that AB is not equal to BA. And that's how it is for matrix multiplication in general. In some cases, when you multiply two matrices, you will get the same answer. Two matrices, when you turn the order around, you'll get the same answer. In most cases, this will not happen. So for mathematics, if you have a rule that works, if you have something that works sometimes and doesn't work at other times, we clearly state that it is not a rule. So can matrix multiplication be commutative? Yes, in some cases. Is matrix multiplication commutative in general? No. So if a question should be asked of you, is the multiplication of matrices commutative? The answer is no. In general, AB is not equal to BA, and so we stated that matrix multiplication is not commutative in general. What that means is if you're asked to find AB you do not write it in the order BA, because more than likely you will not get the same result. So in your multiplication, make sure that if you're asked to find AB, that you actually write them down in the correct order that the question states. This is how we multiply matrices.